Hello and welcome to this section of plotting. We call it the GGPlots plotting. GGplot is a very wonderful and powerful plotting tool that is probably taking over the base R plotting functions, but nevertheless, it's a good thing to master, really, and you can create much more complex plots than the previous ones we created before. So one thing I'll do first is to clear my plots and my workspace. So to clear my workspace, once again, is Control L. And to clear my plots, I can say dev.off. So it takes this plot as a device, okay? It's a plotting device, and I can switch it off by dev.off, and everything goes. So it clears the entire history. So before you use dev.off, make sure you have stored your plots. And I can simply start by defining the base data for ggplot. So ggplot needs a data or a data set. And if I say PL, I'll just assume it's plot. But I don't want to use the word plot because plot is a function in R itself. So I can say ggplot data equals to iris. And then if I run this command, it saves it, but it doesn't create any plots. Now you need to tell it what to do with the data you give to it, right? I cannot say geom bar because I want to plot bar plots. So it accepts geom underscore bar, and you need to have AES, that is the aesthetics, and the aesthetics should be X equals to species. Now, just a little bit of intro into what the dataset looks like again, iris. The iris dataset itself contains several columns, but in ggplot, you can specify the columns without using quotations. And this is very cool. You can directly specify your species. And if it's not working, you can just copy it, okay? Sorry, just copy it, Control C and paste, and it will work. And let's try to see, because we have specified geom bar, and we want the aesthetics to be that we want to be plotted to be species, that is X equals to species. And I can do that by this. Interesting. You see, in this case, you don't have iris $species. It automatically names it as species. And then because this is a bar plot, it counts each of the species and prints it out directly by itself. You don't even need to specify factors here. It just counts it out directly. And you have setosa, you have versicolor, and you have virginica. The next thing that we might want to do is to probably plot from a single column. So you don't need to specify iris $sepal.width, but I want to plot the bar plot for a single column. In ggplot is going to twist the coordinates a little bit. And you have your sepal.width and your what looks like the y-axis, but it should be the x-axis in principle. And this should be your count, that is the number of times each of these things. For example, 2.0 appeared, say, 1 time, and the next thing appeared, say, 2 times or 3 times. But to kind of flip this back, I would use, I can add another layer of function. So that's the interesting part of ggplot. You can continue to add more properties or more features to your plot and make it much more beautiful and advanced. But in this case, I'm not going to add it as an aesthetic. I'm going to add it as another function. And this function is going to be added as quad flip, that is coordinate flip. So you have it plotted, and you can change this to X if you don't want it to flip in the first case, okay? But that works as well. Now you have your coordinates and it has been flipped, but the aesthetics should always be things that are within this table, that is this data frame. And then that is how to basically create a bar plot in ggplot tools, that is ggplot. From here, we proceed to the next video, and in the next video, we'll see much more interesting and beautiful functions of ggplots. Surviving. Mulimashi. Let's see. Let's see. Ah. Oh, Bobby. Hello and welcome to the next hello and welcome to the bar plot section of the plots. It's part 2. Hello and welcome to the bar plot section of the plot of the course. This is part 2, and we want to, in this case, we want to plot much more interesting plots. And before we go ahead, I'll clear my workspace again. And to make it a little bit more understandable, right? We have several data points in this plot, but we want to be able to know which part is the setosa, which part is the virginica, and which part is the final part, which is the vesicular. So to do that, ggplot is unable to understand and merge some form of data together. For example, let's say add into bracket iris. Yeah, so I have species, but then while it can identify some parts, it's unable to identify so let me quickly give you a quick intro to the data set once again, and I have add into bracket iris. Yeah. So when you can plot this part and put a function called fill to ggplots and plot it, we want to be able to clearly see some of the patterns and see the species by ourselves rather than having it all modeled up. So to do that, we kind of have to melt the data set. And how do we melt the data set? We melt the data set using this library, reshape. You know how to install functions already. And then you can now melt this data set using melt into bracket iris. Then when we melt our iris data, I can import my library, and then I can say melt. So when I melt my iris, so this is just a warning that it's using the species as our ID for variables. When I melt my data set, I can simply look at the head. Sorry, I don't want to model up my workspace. I can say head, and I have species. So now it has melted the 4 by 150 into 600 by 3. It has the species for setosa. It has the variable length, so it collects for setosa. It collects the first sepal length and stores it as a value. And going forward, it does that for every other thing. And if you try to look at the shape of our melted iris, sorry, there's a shape. It should be dim into brackets melted iris, and you have 600 multiplied by 3, right? Which is correct because we have 150 by 4 before. And now we have converted the entire 150 by 4 into rows, individual rows. Now, going forward, you can now decide to plot different versions of bar plot. Let's plot this stacked or continuous bar plot. And to do that, you have this kind of ggplots. You specify now your data is melted iris. I did not save it as PL in this case, so I just added something. The next function, I want you to plot geombars. Now, inside geombars, my aesthetics, that is the values that you should take from my melted iris, is to take the variable rows as my X, which is what we have here, is to now take the Y value, the Y as values. That is what should be the height of this should be values. And you should fill it with based on the species, that you should color them based on species. So we have 3 species, and it has colored them based on setosa, vesicular, and virginica. And we have their heights. So sepal length is the biggest, you can see. Comparing all of these. You can have sepal width again. It's not like the third. Petal length, but you can look at the petal length of cis setosa is the smallest overall compared. And you can continue to study various parameters along your plot. I will leave that to you to interpret. So another kind of plot you can create is multiple bar plots. And in multiple bar plots, you can also specify the same method, iris data set. Sorry about that. Then you can specify geom bar. But in the initial state, you have your start to be identity. That is, the identity for the sepal length is still the same. It's still it's using the same set of identity for each bar. But in this case, the statistics is still identity, but now it's going to dodge each of them. It's going to separate each of them. And by dodge, you are basically having multiple bars. And to visualize that, we can see it in this case. So instead of stacking it on top of each other, it separates them into separate bars. And then you have, you can decide to pick which of these two states do you really want to visualize for your data. You can also make bar plots in, pie charts in GGPlots, but you have to do them with the power of called geom bar, right? Geom bar. But one interesting thing is that you can use GGPlots, you specify your iris data set. So we are not choosing the melted iris this time around. And you use geom bar. So the X should be the factor of 1. That is, you are specifying it to be just one column or one location, because it's supposed to be a bar plot. So it's going to plot everything on 1. Then you fill with species, that is, you color by species. Then I want the width of my boxes of my or bars in this, for example, this kind of bars to be 1. And then I will now change the coordinates to be polar. That is, I add another final function that turns it in principle to a bar plot to be polar. And then I'll just it's look like the pole of the globe, right? And then I can plot it. But this is not looking so beautiful like a bar plot. This is looking like a darts game. So what I can do is to specify this variable theta or theta, whatever you want to call it, as y, and then you plot it. And it basically, because this is what we expect, it is 3 different points evenly spaced between each other, 50, 100, and 150. And that's how it goes, okay? And you have your setosa, your versicolor, your virginica. So basically, we are counting the number of occurrences of setosa in our data set, the number of occurrences of versicolor in our data set, and the number of virginicas in our data set. So in the next video, we'll be talking about histograms, and we can see how to plot histograms in GGPlots. See you in the next video. Oh, I need water. So after adding your coordinates, polar, that is what converts it into this kind of bar plot, pie charts rather, we can decide to add themes to our plots. And to add a theme to your plot in GGPlots, the themes specify the look, the outlook of your plot at the end of the day. And to do that, you can simply say theme. You can try to define your theme yourself, but there are some inbuilt themes like theme black and white, and you have it done. So it leaves your color points, but then it gives you this nice frame around your plots if you want. You can also change it to theme classic. Let's see what's in theme classic. It gives you this very thick lines but forget offsets or removes the other two. Let's see another theme. Oh, sorry. Theme gray. Let's see. Team gray is where we were coming from, right? Then you can decide to play with some of the themes that are around. And remember to add your themes as you like. And that's the end of the course. In the next video, we'll be looking at histograms, and we can see how to plot histograms in GGPlots. Hello, and welcome to the histogram section of the course. In histogram, like you know, we want to look at the distribution of our data points. And to look at histograms, we can simply remember that we defined PL in the previous section of this course. I hope you have not deleted it. If you have, you can simply write your PL again by saying PL is GGPlots into bracket data. Your data should be iris. And it works that way. But I'm not going to run it because I have it already. And I can say PL is equals to geom. So I can add geom histogram. That's the function. Remember, previously we were using geom bars, but now we are now using geom histogram. And I'll specify my aesthetics to be sepal width and should color it by species, right? Let's see. So like I said, in the base R plot, it's not going to look so beautiful if you plot it this way. But GGPlots has your back. What can you do? You can decide to plot each of the categories in the species, that is the Setosa, the Versicolor, and the Virginica. You can plot them in facets. And to do that, you can say PL plus histogram. Then you do the same thing, but then this time around, you add another extra function called facet grid. And then you just have to specify dots and this approximation symbol, and then you specify your species. And then when you specify them, you have multiple, right? And maybe to make it a little bit more beautiful, you can decide to adjust it this way, and probably it's looking a little bit more beautiful now. But yeah, you can do that on your PC. And I want to, sorry, I want to add a color parameter to my histogram. Say, yeah, you see, if you look at the previous one, we had it this way. But if I add a color parameter that is within my geom histogram and I put color, it kind of adds something and makes it a little bit more easy to read, and probably to finally make it very beautiful. I can do the facet thing and put it here. You see, it's going to work. And yes, so it probably looks more beautiful. And to further, remember, your plus should be on this line and your facet can go below, right? To maybe a little bit more interesting, I can say themes, black and white. And you see, it's looking much more to my taste. It depends on what your taste is, okay? And this is how you get started. And you see, we are getting advanced a little bit, and we are visualizing our data sets with much more accuracy and beauty. And the next video, we'll talk about scatter plots, which is quite simple. It should be on the simple side. Maybe on R, on base R, it looks a little bit complicated, but here it's going to be really simple. And see you in the next video. Hello, and welcome to the scatter plots video. In the scatter plots section, we'll be talking about scatter plots, box plots, and I would probably add some more themes to some of our plots. So in the scatter plots, we would first of all use create a basic general plot. But the key word for scatter plots is geom points. And with geom points, you specify your axes, your aesthetics rather, that is the things that should go into your plot. Your X should be sepal length, your Y should be sepal width, I want to color all of them as red. Okay, we color it as red. But you can decide to color them by species directly. Instead of using levels and factors like you did in the previous section, you can simply say this, and it automatically colors them. And this way, it also gives you an automatic legend, which you didn't have to do like the previous one. And then you can decide to add some themes if you want. Sorry, theme, BW, I can, yeah, and these are my themes. I can decide to, so I'll do this and I'll try to beautify my plots a little bit more. I would like to start from 0 for both. And I would say to specify the limits in this case, I would say while lim, you see, and I would say C into brackets because I want my Y to start from 0 and end at 4.5, 0, 4.5. And I'll get out of the bracket. I'll get out of this bracket as a whole, plus xlim, that is, I'm adding another layer of function, another layer of function, and this layer of function should be, so I can, it autocompletes, should be xlim, and I want it to start from 0 and end at 8. I will say C into bracket 0, 8, and run it. So you can see that my plots shifted up because all of this part is absolutely unnecessary. Yeah, so that is how to plot your box plot. You can now give it a title using GGTitles if you want. GGTitle. And then I can say my label should be scatter plots. And sorry. Yeah. And it's corrected. I can decide to have a subtitle named width versus length, or sepals alone. I don't want to type a lot. And I can decide to drop this because it's getting too long, and I will say enter. You see, it has given it a subtitle, and that's how you create much more fanciful plots, and you can present them for any presentation or visualization project you are working on. And yeah, to make box plots, it's quite simple. Probably you know it already, geom box plots, and you add notches, which is true. Then I can say my aesthetics should be sepal.length, fill it with species. I want it to be labeled in capital letters, and I give it this theme BW. And then you plot. And you have your plots. You have your setosa, your vesicolor, and your virginica plotted individually. And this way, it's really faster and easier compared to, for me, right, compared to the base R. You can decide to pick which one you want to continue to work on by yourself. In this case, you use theme BW, but you can change it to classic, and it gives you the classic view for those that like classic music. And from now, we'll now talk about heat maps briefly, and then from after that concludes the final part of our visualization section. And then from here on, I believe you should be confident enough with your visualization attempts. See you in the next video. Got this, yeah. Hello and welcome to the heat map section of the course. In this section, we'll be trying to plot heat maps on GGPlots. Before you go, oh, yeah, I did not hear. Hello and welcome to the heat map section of the course. And before we go ahead, we'll try to plot the correlation between some of the values that are present in our iris dataset. So we can decide to calculate the correlation between the sepal length and sepal width, sepal length and petal length, sepal length and petal width, but we can't calculate correlation between an integer set and a character set, okay? So we can't plot any of these against species, but we can also calculate sepal length against sepal width, which we've done, sepal length with petal length, sepal length with just pairing of all the columns against each other. So you are going to now have something really cool that you call a pairwise matrix, and you have something like this. That is, you have, let's say you have your Excel sheet this way. Yeah, so you have sepal length, and you have sepal width, you have petal length, and you have petal width. And on this side as well, you have, sepal length, sepal width, petal length, and petal width. But every time you pair sepal length with sepal length, you always have 1 because it's the same thing, right? So if you are correlating yourself with yourself, it's always going to be the same. But if you correlate sepal length with sepal length with sepal width, you might have something reduced, right? This is 0.2. I don't know the true score. But then this is how it works, and this is how it goes. So everything here, sepal length against sepal width against sepal width will be 1. Just a minute, I will erase this because we don't know what is there. Yep. We know that petal length against petal length will also always be 1, and petal width against petal width will always be 1. And then you have this pairwise matrix, and with that, you can further visualize. Let's see what we have by looking at our data. Okay. And now, what to do? Let's plot our heat map. But before we create the heat map for the correlation, we'll first of all try to correlate the data set, that is everything between 1 to 4. We'll calculate their correlation score. And this will automatically generate a correlation matrix. And for you to see that, you can say run, because I just copied it and it's run. So it's going to create a correlation matrix. And if you look at it, you can already see your 1s, right? And anything above here is also below, but you will see that very soon. Now I can decide to plot my GGplot using my heat map, rather, using the melted correlation matrix. So when I melt the correlation matrix, this is what I have. So it has variable 1, variable 2, and values. So it picks this against this and gives you 1, picks this against this, gives you negative 0.1, and on and on. Then we can now create our heat map using GGplots. Data equals to melt score data. So we are not using the melt data, we are not using the melted iris, and we are not using the raw iris. We are using the melted correlation data. And now to plot, you can now use geom tile, because heat maps in principle look like tiles. I don't know if that's true. Then you can plot variable 1 against variable 2, and then you plot good. And you fuse them with the values, that is the values from here. And yes, so you have petal width against petal width, and then which is the maximum, which is 1. Yeah, sorry, it's here rather. This is petal width against petal width, and it's the lightest, but it's visually difficult to understand, right? Because you may not be able to tell the difference between this box or this tile and this tile. So to do something much more interesting, you can say geom tile, and then you can now use the inbuilt function in GGplot for specifying your own colors. We call it scale fill gradients. Okay, scale field gradient, and you specify what you want to be represented as the low guys and the high guys, which is the blue. And then you can run. So you have your low to be red. That is anything, the low is actually below 1, below 0, right? So it's negative. And the highs, you want them to be blue. A little bit, you can now see the differences, right? And another way might be if you need more advanced representation of these colors, maybe a journal gives you something they call Xcode, and you can browse Xcodes in colors. Yeah, so green is 0, 1, 2, 8, 0, but this is the Xcode representation. Xcode is basically 6 numbers or alphabets, alphanumerics, and you have this hash to represent the Xcode. But then you always have to put it in quotation, because if it goes out of this quotation, everything here becomes a comment, which is not what you really want. So I can decide to, I don't know what this means, but you can decide to look at them. And I think the low represents like blue and the high represents something around chocolate or orange. And going forward, you can also change the X and Y axis. And so by default, if I say scale field gradient 2, it has some inbuilt color parameters, and it uses this and this, which is not so bad, right? But then I can remove the X label using just an empty string and the Y label using an empty string. And that's how it works. You can continue learning about GGPlots and their heat maps, generally plotting and visualization in R using this link. And you can find a way to arrange GGPlots, probably find the solution here as well. And this is where data visualization course section ends. And I hope to see you in other parts of the course, including bioconductor part, the conditionals part, the loops part, and the functions part. And then you can learn fully from there. Thank you, and see you in the next videos.